Now the next question, question number 9. Find the angle between the lines whose direction cosines are given by the equation 3l plus m plus 5n equals to 0, 6mn minus 2nl plus 5lm is equals to 0. We want to find the angle between this. From here, find the value of m as minus 5n minus 3l. Put the value of m here, minus 5n minus 3l into n minus 2nl plus 5l minus 5n minus 3l. Now open the bracket. 6 into 5, 30. 6 into 3, 18. ln minus 2nl, 25 ln minus 15 l square. 18 plus 2, 20 plus 5, 45. ln 30 n square. Take negative sign common. Clear? Now take 15 common. Now this is the quadratic. L square plus 3 ln plus 2 n square is equals to 0. Factorize it. L square plus ln plus 2 ln. Take L common, L plus n. 2n common, L plus n. So the factors are L plus n, L plus 2n. Product of two terms are 0. Either one is 0 or the other. So we get value of L is equals to minus n, or L is equals to minus 2n. Now put the value of L in equation 1. If L is minus n, minus 3n plus m plus 5n is equals to 0, let it be 1. 5 minus 3, 2n plus m is equals to 0. Then we get m is equals to minus 2n. Now put L is equals to minus 2n in 1. Minus 6n plus m plus 5n is 0. Minus n plus m is 0. Then m is equals to n. Note up to here. Therefore, the direction ratios of line are when L is minus n, m is minus 2n, n is n, and other line is when L is minus 2n, then m is n and n is n. That is minus 1, minus 2, 1, minus 2, 1, 1. Direction ratios of the line are proportional to this. Now vectors parallel to these lines are A vector minus I minus 2j plus k, B vector minus 2i plus j plus k. Now we want to find the angle. So cos theta is A vector dot B upon modulus of A modulus of B, or we can say magnitude of A magnitude of B. Dot product minus 2 into minus 1, 1 into minus 2, 1 into 1. Square root of 1 square minus 2 square and 1 square. Minus 2 square, 1 square and 1 square. So what we get? 4 plus 1, 5 plus 1, 6. Square root of 6 into square root of 6, that is 1 by 6. So theta is cos inverse 1 by 6. Theta is cos inverse 1 by 6. Next one is find the direction cosines of two lines which are connected by the relation L minus 5m plus 3n is equals to 0. 7l square plus 5m square minus 3n square is equals to 0. Now find the value of L, 5m minus 3n. Put this value here. 5m minus 3n whole square plus 5m square minus 3n square. Open the bracket. A minus b whole square, a square plus b square minus 2ab. 15 into 3, 15 into 2, 30mn plus 5m square minus 3n square. Multiply the terms. 25 into 7, 9 into 7 minus 210 mn plus 5m square minus 3n square. M square 175 plus 5 180 m square minus 210 mn plus 60 n square. Take 60 common. 3m square minus 35m plus n square is equals to 0. So what we get? 3 30 common. 6m square 7mn plus 2n square is equals to 0. So 6m square minus 7mn plus 2n square is equals to 0. Now factorize it. 6 into 2 12, 4 into 3 12 and 4 plus 3 is 7. From here take 2m common. From here take n common. So the factors are 3m minus 2n and 2m minus n. 3m is equals to 2n or 2m is equals to n. So what we get? M is equals to 2 by 3n or m is equals to n by 2. When m is equals to 2 by 3n, put this value in equation 1. L minus 5 into 2 is 10 by 3m plus 3n is equals to 0. Value of m in terms of n. 3 into 3, 9. So minus n by 3 is equals to 0. So we get L as n by 3. So the one direction ratios are proportional to when L is n by 3, m is 2 by 3n and n is m. So the direction ratios of line are proportional to this. Now second is when m is n by 2. L, m is n by 2 plus 3n. Instead of m we put the value n by 2. L 3 into 2 6 minus 1. So we get L as minus n by 2. Direction ratios of other line is L is minus n by 2, m is n by 2 and n. That is direction ratios are 1 by 3, 2 by 3, 1 and minus 1 by 2, 1 by 2 and 1. Now we want to find the direction cosines. By taking LCM, we can write it as 1, 2, 3, minus 1, 1 and 2. Now the direction cosines of lines are 1 upon 1 square, 2 square, 3 square, 2 upon direction cosines of other line are minus 1 upon 1 square and 2 square, square root of 6. Minus 1 upon square root of 6, 1 upon square root of 6 and 2 upon square root of 6. So these are the direction cosines of the required line. Now next one. If a variable line in two adjacent positions has direction cosines L, M, N, L plus delta L, M plus delta M, N plus delta N, show that small angle delta theta between two positions is given by delta theta square is equals to delta L square, delta M square and delta N square. Now since LMN and these are direction cosines, we know that L square plus M square plus N square is equals to 1. L plus delta L whole square, M plus delta M and N plus delta N whole square, that is equal to 1. Now open the brackets. We can write it as A square plus B square delta L square, delta M square, delta N square plus 2 AB, L into delta L, M into delta M and N into delta N. यही होगा A square plus B square plus C square, A plus B whole square, A square plus B square plus 2AB, that is equal to 1. Now we know L square plus M square plus N square is 1, that is equals to 1, and this is delta L square, delta M square plus delta N square plus 2 L delta L plus M delta M plus N delta N. 1 will get cancelled. So 2 times L delta L, M delta M, N delta N is equals to minus delta L square plus delta M square plus delta N square. Now this 2 goes on the right hand side, so it becomes minus 1 by 2 this. Let A cap is unit vector along this line, then Li plus Mj plus Nk, and B vector, B is unit vector along this L plus delta Li, M plus delta Mj and N plus delta Nk. Let this equation as equation number 1. Now we know cos of delta theta, this into this, so L into L plus delta L, dot product of these M into M plus delta M, N into N plus delta N upon square root of L square plus M square plus N square, delta L square plus delta M square plus delta N square. L square plus M square plus N square has value 1. Since both of these are unit vectors A and B, therefore magnitude of that is equals to 1. So denominator has value 1. Now open the brackets. Cos of delta theta is equals to L square M square N square, L delta L, M delta M and N delta N. L square plus M square plus N square has value 1. Put the value of this, that is 1 by 2 delta L square, delta M square plus delta N square. Clear? Now this one goes on that side. and the negative sign. First it becomes cos theta minus 1 is minus 1 by 2 delta L square, delta M square and delta N square. Negative sign goes on that side, then it becomes 1 minus cos theta. 2 goes on left hand side. What is the formula for 1 minus cos theta? Delta M square plus delta N square. We have cos 2 theta is 1 minus 2 sin square theta. 1 minus cos 2 theta is 2 sin square theta. Angle is half, so it becomes 2 sin square theta by 2. Delta L square plus delta M square plus delta N square. Sin square delta theta by 2. So 2 into 2 is 4. Since angle delta theta is very small, delta theta by 2, so instead of sin square delta theta by 2, we write it as delta theta by 2. Instead of sin delta theta by 2, we will write delta theta by 2 because this angle is very small. Right hand side remains same. So 4 delta theta square upon 4 is equals to delta L square plus delta M square plus delta N square. This will get cancelled. So we get delta theta square is equals to delta L square, delta M square and delta N square. This is what we want to prove. Note up to here. Now the next one. Prove that the straight line whose direction cosines are given as by the relation AL plus BM plus CN equals to 0, FMN plus GNL plus HLM is equals to 0 are perpendicular if F upon A, G upon B, H upon C is equals to 0, parallel if A square F square plus B square G square plus C square H square minus 2AB FG minus 2BC GH minus 2AC HF is equals to 0. From here find the value of N minus AL plus BM upon C. Put this value of N here. FM AL plus BM upon C, GL AL plus BM upon C plus HLM equals to 0. Solve this equation. Minus FAML minus BFM square, take the LCM with C, minus AGL square minus BMGL plus HCLM equals to 0. Now take the negative sign common. AGL square plus FAML plus BMGL minus HCLM plus BFM square is equals to 0. We can write it as AGL square. From here LM is common, so AF plus BG minus HC LM plus BF M square is equals to 0. Now divide this whole equation by M square. We get AG L upon M square, AF plus at C, L upon M plus BF is equals to 0. Now this is the quadratic in L upon M. If general equation of quadratic is this and its roots are alpha beta, then we know sum of roots is minus B upon A and product of roots is C upon A. Now this is quadratic in L upon M, so its roots will be L1 M1. Its roots are L1 M1 and L2 M2. Now we want to find product of root L1 M1, L2 M2, C upon A. L1 L2, so what we get? L1 L2 upon BF is equals to M1 M2 upon AG. We can write it as A L1 L2 upon F, B M1 M2 upon G, or L1 L2 upon F upon A, M1 M2 upon G upon B. Similarly, यहाँ तक करने के बाद now we want to find this equation in the form M upon N. This is of